have your property packet as you go through this. So if you still have that property packet and you'd like it in front of you so you can flip through it, that'd be great. Today we're going over the segment ones. So those are the segment properties like segment addition, postulate, stuff like that, midpoint theorem, any of those. Okay, but you still have some of those algebraic properties in there as well. So just a reminder here, theorems are statements that can be proved. Okay, so those theorems that we're using, somebody came up with a formal proof behind them. That's why you're able to use them. Okay, and postulates are statements that are accepted as true. Okay, so those ones don't have that proof. So your two-column proof process, these are your different steps that you can take. Some of them are in your head, but my poster about this is on the floor right now because it won't stay on my wall. It's over here. It's on the floor. But step one is to draw a picture. Now, most of the time, I will have a picture next to the proof for you. Okay, I will have a picture next to the proof for you. You won't have to draw it out yourself. However, you will have to label it. Step two is to understand what you're given. So look at that given information and look back at your picture and see where that is within that picture. Step three is to understand what you need to prove. You'll be given what you have to prove as well. So you have to take those steps all the way down to see what you have to prove, just like our algebraic proofs. Okay? Step four is to mark your picture. So you can mark your picture using that given information so that it'll help you figure out where you need to go next. Step five is to look for freebies. So those are things like vertical angles or shared sides. We'll do more with freebies in angle proofs. And then we'll do a lot more with freebies in triangle proofs, and that's in chapter 4. Okay, but you still should look for those freebies within your picture. Step 6 is to work out the proof in your head. So look at it, say, okay, I can do this step, and then I can do this step, and then where can I go from there before you even start writing anything down. And then step 7 is to write the proof. Okay, and then justify each statement with a reason. Okay, those reasons are your definitions, your algebraic properties, your postulates or theorems. Those are all in your packet. Okay, so everything on the right-hand side of your two-column proof are your properties in your packet. So there are two different kinds of proofs. We have paragraph proofs and two-column proofs. Yeah. So paragraph proofs are writing sentences to explain why the conclusion is true. So each sentence cites the reason justifying why it is true. Reasons can be definitions, algebraic properties, postulates, or theorems. And we will get into paragraph proofs, but we are just going to start with two-column proofs so you know that layout and how to figure out your reasons behind each step. Okay, so two-column proofs contain statements and reasons organized in two columns. So your statements, just like our algebraic proofs that we went over, are on the left-hand side. Okay, so those are the steps you go through to get to what you're trying to prove. Your reasons of why you can do each step go on the right. Okay, so one way or one strategy is working backwards. Okay, so one strategy for writing a proof is to work backwards. Start with what you're trying to prove, and work backwards step by step until you reach the given information. Okay, so if that works for some of you, you can do it that way. So look at what you're trying to prove and go from, well, I have this, so I would have to have that, and then have to have that before I could have this. Okay? So we are going to try some of these. So again, if you have your property packet, I suggest you have that out so you can flip through and know why I'm writing the statements I am or the reasons that I'm writing down. All right, so today is just segment proofs. Okay, we're just looking at segments. I think that's on this third page of your property packet. I don't remember. So, first step is to draw a picture. Well, I already have that picture there for you. Okay, like I said, that picture will usually be included for you, so you don't usually have to draw it out. Next step is to understand what you're given. So in each one, you have given information. Here, this one says BC is equal to DE. Okay, those two segments are equal to each other. Okay, that's all that I'm given. I need to prove, okay, third step is understand what you have to prove. I need to prove that AB plus DE is equal to AC. Okay? Next, I want to mark the picture. So I want to mark the picture with what I was already given. So if these two segments are considered equal, they're also congruent. So I can mark those as congruent. So make sure you're marking your picture. You have to refer back to that picture. Okay? Looking for freebies. So with this one, you don't have vertical angles, right? We're not talking about an angle. Okay, we don't have a shared side. But I know I have these two pieces with a whole segment, correct? Right? So couldn't I take this smaller piece AB plus this piece BC to get AC, right? Since I'm trying to set up an equation of segments. You see where I'm getting that from? Do you remember what that's called when I add two pieces together to get the larger? Which property is that? The segment addition postulate. Good. So somewhere in my proof, I'm going to probably have to use that. Okay, that's what it's saying by look for freebies. Look at your picture and what could you come to a conclusion of behind what's just given in that picture. All right, so we're going to kind of work out this proof in our head here. Now, I notice I only have 3 steps. See that? I have 3 steps written for you in this proof. So, since these two are equal, and I told you we're going to use that segment addition postulate, right? Where I'm going to add these two to get the total. Well, since these two are equal, can't I replace BC with DE then? Since they're equal, right? All right, so then we're going to look at our proof. Now in our proof, what do we always start with? The given. Good. Okay, so I have our first statement was our given information. And the reason is because it was given to us. Okay, next I'm going to use that freebie that I kind of thought about in my picture, right? So I'm going to add together my 2 smaller segments to get the larger, and that is the segment addition postulate. So I would write this as AB, okay, our first smaller segment, plus BC is equal to AC. Okay, and again, that is the segment addition postulate. That's why I could write that out. Now, I did say before how I was going to finish solving this, right? I said since these 2 segments are equal, I can replace BC with DE. Okay, so here I was replacing BC with DE. Okay, so changing from one step to the next there. Now if I replace something, what is my property? If I'm replacing something within an equation that it's already equal to. It's substitution. Okay, I'm substituting DE in for BC. Now this last statement right here, okay, you see this last statement? It should always match what you're trying to prove. Okay, so this right here should always be your last statement. Does that make sense? Are you still with me? Yeah? All right, we're going to go do a longer one. This one has 8 steps. You ready? Yeah? All right, so again, first thing we're going to do is look at the given. Okay, we are given that Q is between P and R. Okay, Q is right here. It's between points P and R. We can see that in our picture. Okay, R is also between Q and S. Okay, again, you can see that in the picture. R is between those 2 points. Last thing that we're given is PR, okay, this segment right here, is equal to QS. Okay, we need to prove that PQ, this little segment, is equal to RS. That smaller segment there. Okay, you see that in your picture? Always look back at your picture. Don't ignore it as you go through your 2-column proof. All right, so next I want to mark up this picture with what I'm given. Well, I already have Q is between those 2 points and R is between these 2 points. Can't really mark anything up with that. I can, however, mark PR is equal to QS. Now to do that, I'm going to create separate segments here and label those. However, you need to label your picture so you understand what it's talking about. Okay, so PR equals QS. All right, freebies. Whenever you see a point is between 2 other points, you have to use the segment addition postulate somewhere. Okay, so Q is between P and R. Okay, I need to use the segment addition postulate there. And R is between Q and S. I need to use the segment addition postulate there. Okay? So that would be your freebie in this one. So I'm going to start reasoning through this proof. Okay, just in my head really quick. Or you can think about it in your head really quick. Okay, so kind of think about what you're given here. If I use that segment addition postulate, and I know these 2 pieces are the same, right? I can start replacing things. Okay, so I can start replacing and substituting things in that are equal. That's how I would reason through this. So, starting our proof here, we're going to start with one part of our given. Okay, Q is between P and R. Okay, that was given to us, right? I want to use that information to create the next statement. Okay, since I was given that Q is between P and R, I'm going to use that to say PQ plus QR is equal to PR. Okay, why is that true? Why can I add those 2 smaller pieces together? The segment addition postulate. Yes, I abbreviated it with just add. Okay, Next statement. I haven't used all the pieces of my given yet. Okay, this one says R is between Q and S. Okay, that was given to me. So what should my reason be? Given. Now I want to use that given information to write my next statement. So since R is between Q and S, can't we again use that segment addition postulate? Right? So QR plus RS is equal to QS. Okay, whenever you're given that betweenness of points, you should use the segment addition postulate. Okay, my next statement here says PR is equal to QS. Well, I wrote that on my picture. Why did I write that on my picture? PR was equal to QS. Because it was given. Okay, that was the last piece of information that I was given. So now what I want to do is use what I was given and my other two statements here to come up with the next statement. Okay, so here I know PR. Okay, I have a PR up here. It is equal to PQ plus QR. So I'm replacing this PR with what it's equal to from up here and bringing it down here. Okay, so instead of PR, I have PQ plus QR. Okay, same thing with QS. Okay, QS was equal to QR plus RS. So I'm taking that information and replacing QS with that. So if I'm replacing, okay, what is that replacement called? Substitution. Okay, I'm substituting what those were equal to. Okay, next, I want to see what changed from 6 to 7. What do you notice about statement 7? This QR, right? If I'm subtracting QR from both sides, what is that? It's an algebraic property. That is the subtraction property of equality. Okay, if you're subtracting something from both sides of your equation, there's an equal sign. Okay, subtracting from both sides, that is subtraction property of equality. Now, if I look at statement 7 and I have QR minus QR, right? Those would cancel each other out. And then here I have QR minus QR. Those would cancel each other out. I would be left with PQ is equal to RS. Does that match to what we were trying to prove? Okay, it does. Okay, this is what we were trying to prove. That should always be your last statement here. Okay, and that's because of a subtraction fact. All I did was subtract those two segments to get that final statement. Okay, do you have questions on how I did any of the statements or the reasons? All right, the last ones here are one-step proofs. You've done these before. Okay, so number 3 here, you're given that segment DE is congruent to segment GH. Conclusion is that GH is congruent to DE. Okay, here you're just switching. Okay, if you're just switching your two segments, do you remember what property that is?
Symmetric.
The symmetric. Okay, symmetric property switches. Okay, number 4, we have segment AB is congruent to segment RS, and segment RS is congruent to segment WY. The conclusion then is that AB is congruent to WY. Well, AB was equal to RS, and RS was equal to WY. Since both of these are equal to the same thing, they have to equal each other. Do you remember which one that is? What? Because it's symbolic. If I wrote that all out, it'd be like a paragraph. This is the transitive property. Okay, last one. We have AB is equal to EF plus FG, and BC is equal to EF plus FG. Those are the same in both. Conclusion, AB is equal to BC. Okay, since both of those are equal to the same thing, they have to equal each other. Okay, again, that is the transitive property. Now, if you would have said substitution, I would have accepted that too. So you could say you're substituting BC in for EF plus FG since it's equal to it right here. Okay, I do want to give you some time to work on these and ask questions. Okay, that's why I only had 2 examples of a 2-column proof here. We will go over some more of this tomorrow. Okay, so we're going to practice more tomorrow. We're not going to move on after that. Okay, we'll practice.